Hello, everybody. This is Mr. Roth, and hope all's well on your home isolation therapy that you're going through right now, and not too boring. In any case, I finally figured out how to get my screen recording going, so hopefully this is helpful. I'm going to go back a couple days and just talk through FM21 because inverses function composition, I don't know, they're a little bit different, so it might be helpful to go back and just do a summary. And this will make it quicker. Normally in class, of course, we go through and do this step by step by step, and then we take a while to go through it. But it looks like these recordings are going to be really big. And since you've already looked at this, maybe just talking through the answer keys, so to speak, will be helpful. Okay, so when we start this in class, we start way over here. Hopefully you can see my little mouse moving on the screen. And we have a quadratic, x squared plus 2. Simple equation. We're all super familiar with it. And I graph that, and then we go through and then graph the parabola over here. Okay, easy enough. The next, and here's the domain, here's the range, all familiar stuff. And notice I did it in blue, and then I do this one in pink. It is very helpful throughout these things to use different colors. You'll see why in a sec. So, is it a function? I didn't write it on there, but indeed, yes, it is a function. Then the next thing we do is I say swap x and y columns. Now this is before we said anything else. I just say do it. Swap the x and y column. So the x became the y and the y became the x. And then we make the graph of those points and connect the dots, and we see that, hey, look, that's a sideways parabola. The next thing, and I'll erase these things, we don't need that junk on there. The next thing we talk about in class is say, well, what translations did you notice in that process? And then somebody always says, oh, I remember from last year, that's our 90-degree rotation. So that's this section right down here. And then somebody will say, hey, it's also a reflection of the line y equals x. And maybe somebody else has some other translations they think about. But the big deal, the one that we want to focus on is this reflection. It will sometimes be a rotation, but the reflection over line y equals x is the key idea for inverses. And if you remember back from geometry, actually that is exactly how you got the reflection over line y equals x, is you'd swap the x and y. That was one of those mappings that you did last year in geometry class. So, okay. And then the next thing is, okay, fine. What equation makes this graph? And you can just look over here and say, well, I know we just did a radical graph, and the vertex-y kind of thing, this point right over here, was a right 2 translation. So, well, that had come from the square root of x minus 2. But there's also a top and a bottom half, and I know the negative flips it over the axis, so fine, there's that negative right here. Okay, so this must be the equation that would graph this. The positive side is the top half of the radical, and the negative is the bottom half. Now, this is a misnomer. I don't know, we're using this m-1 of x, and we'll talk about the inverse function notation a little bit more, but this isn't actually a function. It doesn't pass a vertical line test, but yeah, we'll just use it anyway. It won't be super formal here. The key idea is this equation right here is the full inverse of the original blue function. All right. And then we go through and we say, okay, fine, no, it's not an inverse function. And by the way, it's very easy with this inverse notation. The -1, and I'll circle it in pink right here, this -1 power that I'm using here, it doesn't mean 1 over m of x. It's a different notation. If you look on your calculators, last year in actually geometry, the first time you came across the inverse notation was sine. And if you look on your calculators, you'll see the sine -1 notation. I think you did that last year in geometry class. So that was your first exposure to this inverse function notation. Okay, in any case, function composition. Function composition, I'm plugging one function into another. And the key idea is I take, in this case, see, this is where the coloring really comes in place over here. I take my inverse m-1 of x function, not function, but equation, and I plug it into the original m function. And by definition, an inverse function undoes the work of the original function. Kind of like your younger brother or sister when you clean up your room or the house and then they make a mess again. So in any case, this If I take, and everywhere there is an X in the original blue, like this X right up here, and when I write this out, I open up parentheses. Wherever the X was here, notice that there's this big blue parenthesis right here. And then I plug the inverse function, this, into that spot where the X was. And then when I simplify the function, lo and behold, I plug X into the inverse function. I do some work on it. The output from the inverse function is then the input into the blue original M function, and they cancel each other out, and I end up back with X again. And that's how you can prove inverses of one another, because if you compose them together, you plug X in, again, into the original purple or pink M function, and then through that process of taking the output of the inverse, plugging into the original function, you get back to X again. Same thing, it works both ways. Plug the inverse into the original, or plug the original into the inverse. In this case, it's a plus or minus X, and that's just the nature of the fact that it's not really a function, so don't worry about the plus or minus X in this case right now. Okay, so, I mean, that's the essence of the thing. And here's, looks like here's the note from last year where the inverse undoes the work of the original function. Now, how do I get this equation right here? In B, it looks like it introduced a step-by-step process. How do I get this equation if I haven't really gone through this graphing process and I don't have an easy way to do that? So we think about the steps we did. What did we first do here when we did this here? We swapped X and Y columns, and then we graphed it, etc., etc. So we do the same thing here. If I look at the f of x function here, 3x plus 5, well, I know the x and the y are going to want to swap roles, and so I swap x and y. Hopefully you can see step 1 here. You see, hopefully you see the little mouse moving okay. I swap x and y here, and f of x becomes the x. The x here becomes y. Now, the first thing I really should do is, let's see, where did I do this over here? Here's step 1. So notice f of x here became y, because it's just weird. You can't really put f of x down here. So if you have function notation f of x, just turn it into y. So it's easy to swap x and y then. So I'm looking down here. The x became the y became the x became the y, and then notice that it says here solve for your new y, step 2. So I did that right in this step, and then you get y equals 3, you know, the x minus 5 over 3, and then don't forget, name your new function. Instead of y, it is now f negative 1 of x, because it's using, well, does everybody see it right there? It's my new function notation. Okay, fine. When I graph that, then I did this in a different order last year. Then I graph and I say, well, is that a reflection across the line y equals x? I'll graph that here. Indeed it is. It looks like if I fold the paper across this on this dotted line, the blue line would go over the top of the pink line, and indeed they are functions. So it all seems to work out nice. Now, went through the function composition to prove inverses again, and notice I still am color coding this, where I do the, blue is the original function, pink is the inverse function, and then plug the blue into the pink and the pink into the blue. Both ways you do it, you'll notice it composes back out to x. Anything new here? I don't think there's, well, it's not just with quadratics and linears, and it works for all different kinds of functions. Notice that a cubic ends up creating a cube root as its inverse function when you go through the steps. Again, the first step we did here, this m of x, I turned it into a y, and then this y got turned into the x here. This x cubed became the y cubed. And then when I'm solving for this y, step 2 right here, and the last thing, don't forget that y gets turned back into a m negative 1 of x. Okay. Ah, the last but not least thing here. Maybe D, this section was confusing to you because we don't have equations. It's just a mapping of points. Plugging the x, the x is mapped over to the y, and the y is mapped into the x. Actually, I think I'm going to start this as a separate video because it's probably getting really big right now. So maybe I'll pick this up as video 2 for this section. Look it up. Goodbye.